Throughout the course, we've been talking about scenarios for the future, and we've seen this plot a number of times showing the temperature changes in the future based on different scenarios, from the most optimistic at the bottom to the most pessimistic. And the scientists basically came to the policymakers and said, if we don't want to have dangerous climate change and irreversible climate change, we'd have to have a target of, say, 1.5 degrees. Originally, this was 2 degrees, the Paris Agreement. You can see this little gray band on the plot. So originally 2 degrees was the threshold, but that's been now moved down to 1.5. We don't want to cross a global warming of 1.5 degrees to not have some dangerous, irreversible climate change. So what do we need to do to get to this target of 1.5? Well, on this plot, and you may have heard of many times of what's called net zero by 2050, and I'll talk about what this means, net zero. On this plot, we can see the addition of carbon dioxide into the atmosphere every year from our man-made activities, which is around 50 gigatons per year, 40 to 50 billion tons of carbon dioxide every year. And if we go on our paths, even with some of the international agreements, we'll follow the red lines here, which means that every year we're putting more and more carbon dioxide into the atmosphere. In fact, we put a lot more than 40 or 50, but we have help from the oceans and from the biosphere that take out a lot of this carbon dioxide through photosynthesis and absorption in the oceans. But what's left is about 40, 50 gigatons every year. So if we want to solve this problem, instead of following the red lines, we need to follow the green curves. And what does this mean? It means that by 2050, we'll reach zero net emissions. And this is what we talk about net zero. It means it's not zero emissions. It means if we put anything into the atmosphere, we have to take it out somewhere else so that we have a net zero addition to the atmosphere. And to do that, basically what we have to do is we have to cut in half the emissions of greenhouse gases from today until 2030. We have to then cut them in half once more until 2040 and cut them in half once more until 2050. If we can reduce by 50% the emissions every decade, we'll get to approximately zero net emissions by 2050. And if we continue doing this, we can actually have negative emissions when the green curve goes below the zero line, which means we'll start to take out more carbon dioxide that we're putting in, and eventually then we'll start to see the planetary temperatures starting to cool down. So this is a huge challenge, how we get to really net zero emissions by 2050, but there is a roadmap we can follow, and it's still possible to get there by 2050 to this net zero emissions, which will help us solve the climate crisis. Now, the biggest problem is that our emissions come largely from the use of energy. We can see on this plot the global emissions, the greenhouse gas emissions from the different sectors, 73% just from the use of energy, from the lights, our electricity at home, driving our cars, our industries, everything that needs energy is producing greenhouse gases. We can divide this up into the different sectors. We also have we've spoken through the course about agriculture, forestry, land use, waste, industry, but energy is really the biggest problem. And without solving the energy problem, we're not going to solve the climate crisis. So what is this net zero everyone talks about? Net zero basically means that the greenhouse gas input into the atmosphere minus the output from the atmosphere has to equal zero. Or the greenhouse gas input into the atmosphere equals the output. So we have a balance. What goes up has to come down. Unfortunately, today, the input of greenhouse gases is much, much more than the output of greenhouse gases. As I mentioned, the oceans and the biosphere do help us, but still we're putting in so much into the atmosphere that there's no balance, and we're building up continuously the amount of carbon dioxide in the atmosphere. So in order to solve this problem, we need to reduce the inputs on the left-hand side of that equation, and we have to increase the outputs. We want to reduce how much we're adding in the atmosphere, and we want to increase how much we're taking out in order to get to a balance of zero. And there are basically 6 things we'll talk about in this week about how we can actually achieve this. So in the top box, we can see the things we can do to reduce the input into the atmosphere. First of all, we need to move dramatically to renewable clean energies like solar, wind, biomass, maybe even nuclear, and we'll talk a little bit about this. Once we have this clean energy, we have to electrify everything. That's the second point. We have to electrify our cars, our trucks, our trains, maybe even planes. But we need to use the clean energy from the first point. Now, not everything can run on electricity. So the third point is we may have to develop new types of fuels for energy. And the main one people are talking about is hydrogen. Hydrogen, and we'll talk about hydrogen, but there's also synthetic fuels for aircraft, for ships. And then there's also a sector which doesn't really involve that much energy, and that's the agricultural sector, producing food for 8 billion people, land use, deforestation. We've spoken about this during the course. All of these are contributing to more greenhouse gases in the atmosphere, and we need to reduce them as much as we can. And then on the other side of the equation, we have to increase the output. We're taking out the carbon dioxide from the atmosphere. And here we have two possibilities. One we call nature-based solutions. Again, we know that the oceans and the forests help us here, but can we actually increase this? Can we increase the forest cover on planet Earth? Can we increase the photosynthesis in the oceans to help us take out more carbon dioxide? And the last point is actually technical solutions, such as carbon sequestration, physically sucking out the carbon dioxide out of the atmosphere or out of the oceans. And we'll talk about each one of these points a little more in the rest of the class.